Hello everybody, this is Deniz, and in this video I'm going to show you how to implement decision trees in Rapidminer. In the last sessions we talked about how decision trees are using the information gain in order to create the branches of the tree. So now I'm going to show you how we can do that in Rapidminer and how we can also display the weight by information gain of the attributes. First of all, I'm going to require a dataset, and for this example, I will use the mushroom dataset. Let's go ahead and drag and drop one read CSV block. Okay, so I'm going to load the mushrooms dataset from the CSV. Well, we can take a look at those later. Let's just go ahead and see what we have in this dataset. All right, what I can see is that we have a bunch of attributes, and all of them seem to be categorical. Even my class is categorical, and it is not assigned as a label. So we have just another attribute here. All right, so if you take a look at the statistics part, you will also see that most of the attributes are polynomial, meaning that they are categorical. Right. So because we are dealing with a supervised problem, we need to set the role of our target, of our label, right? So we are interested in the class attribute, and we would like to assign the role of label there so that we will be able to provide labeled data to our machine learning models. All right, so the operator that we use for decision trees is called decision tree. No surprise there. All right, so if we go ahead and run, we will see the decision tree itself. Okay, so we have branches. I will just zoom out. You will not be able to see the names, but we have branches and we have leaves. So this is the decision tree, right? Okay. All right, so at this point, maybe it's a good idea to check the information gain. And what I can do is to use a weight by information gain operator. Yeah, this one. But I would also like to keep my decision tree here, so I'm going to multiply the data by using a multiply operator. Here it is. My labeled data goes as an input to the multiply operator, and the first multiplied part goes to the decision tree, and the second one goes to weight by information gain operator. Here are my weights, and I would like to sort them in descending form so that we have the attribute that provides the highest information gain at the top. We'll go ahead and run. All right, I can see that the order has the most information gain. And at the second level, we have the spore print color. So this ranking is also going to provide me the order of the branches within the tree. If you take a look at the tree, now remember, the first one is odor, and the second one is spore print color. If you take a look at the first level branch, it's odor, and the second one is spore print color. This is because decision trees they are using weight by information gain. So based on information gain, they are providing these branches. So let's go ahead and do some operations on our process here. First of all, I would like to measure the performance of the model, right? So in order to do that, I will need to apply the model first. Apply model operator is here. I'm gonna need that after decision tree, like here. Yeah, but apply model requires unlabeled data as well. For the time being, I will just go ahead and connect the labeled data there. So this is the training data. It's not what we are supposed to do. But let's go ahead and run. What are we missing? Yes. All right. We are missing the outcome of the apply. Yeah, there we go. Maybe it's better that I just put these operators far away from each other so that we can see the inputs and the outputs better. Like this and like that. Yes, it's more beautiful now. Tidy. There we go. So we have the apply model. So this is the outcome of the model. We have the prediction, the predicted class as a new column introduced. But we still didn't measure our performance. To do that, we will just check performance and classification performance. I think that should be the first one. Yes, performance classification. I'll put that here. Okay, it's tidier now. Let's go ahead and run. Here is my performance tab, and in the performance I see that it's 99.9 accuracy because we are measuring the the training set. And here is our confusion matrix. But let's go ahead and implement this properly. Now this time I'm going to use a cross-validation. Here we have the cross-validation. I'll put it here, and then I'm going to just delete those two and the decision tree as well. But I will keep the multiplication and provide the labeled data to my cross-validation block. And within the cross-validation block, I double-click on it so that the detailed cross-validation, I will need to select my the algorithm, which was decision trees, right? So here we have the decision tree. We are providing now the labeled data, and the model comes out from here. And now what I'm going to do is to apply the model at this point. But the cross-validation, the entire block here, is also managing the creation of the unlabeled sets. So what it does is to run iterations, which I specify actually. So here the number of folds is specified as 10. It means that this is a 10-fold cross-validation. So what it's going to do is to run the iterations 10 times. Well, it's going to be 10 iterations. And at each iteration, what it's going to do is to create one small set of test data, and the rest is going to be used as training. Then it's going to shift that test data. All right. But no, we also need to measure the performance. For that, we need the classification performance. Classification, performance classification. Yes. All right, so let's connect these. And this goes there. No, I made a mistake. Yes. Yeah. All right. We didn't connect the outcome of the cross-validation to my process outcome. I'll go ahead and connect everything. And in the end, what I'm going to see, where is my... So performance goes as an outcome. And which one is our performance? There you go. We just didn't connect. All right, so we have the performance of the cross-validation here. It says 99.77 accuracy. And we also have our confusion matrix that is an outcome of the cross-validation. So that was it.